start. Okay, I want to do a poll. How many of you here use Graphene OS? 3 people. How many of you use an open source router? Few people. How many of you use Venice AI or Near.ai? Nobody. One person, two people. Do you work at Near? How many of you use Nix? Gix? Cubes? Okay. We have a group of people that may or may not understand what we're going to talk about. So why sovereignty starts with hardware was the title I was assigned. Colby talked a lot about like things other people do, in the sky, on farms, preparing for the apocalypse. I want to bring our attention to concepts that are very personal. And so when I think about what personal sovereignty means now on a day-to-day basis, like maybe it could mean I use Graphene OS on my Pixel, I connect to a VPN on my phone, which is connected to my open source router, on which I have another company's VPN, so I have a double-blind connection. And then when I talk to AI, I use some of these confidential inference services like Near.ai, Venice.ai, by their tokens. And these models are run in trusted execution environments for confidential inference. And also because I like being very frustrated, I use any of these crazy operating systems like Nix, Gix, Cubes. All right, so if you kind of use that stack, you feel I'm personally sovereign. For the people to whom these words make no sense, don't worry. These people, I'm not sure have it right either. In this talk, I'm going to show you we've been distracted from the thing that really matters. Think about your hardware. You can have all the cryptography, obfuscation, succinct, non-interactive proofs of knowledge, but if the layer at the bottom is not secure, the hardware right at the bottom, then all of these acronyms may just be for self-entertainment. Let's start with a very famous example many of you probably have heard of. It's about the NSA sticking implants into Cisco routers. For those who aren't familiar, from at least 2010, the NSA would intercept shipments of Cisco routers being delivered to targets around the world. So they would grab these boxes, cut it open, install a physical implant, reseal it, and then send it on. This is a very famous photo by Glenn Greenwald. And you can see them unsealing the boxes. There's Cisco upside down there. This implant was called JetPlow, and it installed persistent backdoors. Basically, it would rewrite the device's boot firmware, basically code that runs before the OS loads. And every time the router powered on, it loaded NSA code first. And this is the backdoor. It would phone home to NSA infrastructure. Because it lives in firmware, you couldn't easily detect it. But JetPlow was just one in a 50-page catalog of implants for tools like that. And it was like a menu. If you want to hit this router brand, this server BIOS chip, this hard drive, even some USB cables, you just go to this restaurant menu for data exfiltration via hardware. And while we know this is true of the US cannot be the only country with these menus. Like logically speaking, any technologically advanced state would have some sort of menu, or to my knowledge, any country with ties to some of these countries. Like people who perhaps they're in dictatorship-like environments who have ties to some of these technologically advanced states. These are the tools they would use to surveil their citizens. All right, so we did the famous router example. Let's do a phone example now. Your phone has 2 processors. You have the application processor, it runs your OS, your apps, everything you see and interact with. What you don't see is the baseband processor, which is a completely separate chip. It manages the radio, it talks to cell towers, it has its own firmware and its own operating system, which is completely independent of your application processor. And it can receive instructions over the air from your from your network so that carriers can do legitimate things like network configuration or updates. So story time, it's 2006. The FBI is investigating a New York mafia. And the suspects are very smart. Before they start a sensitive meeting, they turn off the phone. But then somehow the FBI seems to have been able to bug these meetings. How? It's not 100% clear, but some of this shows up in court documents. The most technically precise account says they pushed modified firmware over the air to the baseband processor. And this firmware made the phone pretend like it shut down. The screen goes dark, but the baseband processor is still alive, and it has direct access to the mic. And that's how they were able to listen in to the secret mafia meetings. So we went from routers to our phones. Let's now go to our computers. I think many of you know that every Intel processor since 2008, whether it's the i5, i7, i9, contains something called the Intel Management Engine. It's a separate processor core inside the main chip package with its own firmware, own network access. And it was actually designed for a legitimate purpose, enterprise IT management. I don't know how many of you here are familiar with enterprise IT management. I remember I used to have a ThinkPad, and some guy somewhere would help me manage the laptop. But basically, it's so that an IT admin can reach it through the management engine, even if the machine is powered off and the OS isn't running, which is kind of shocking, but enterprise needs. This ME's firmware is closed-sourced, and it can't be audited by anybody outside of Intel. And you can't actually disable it, kind of. In 2017, researchers reverse engineered this ME firmware, and they found a reference to something called a high assurance platform, which if you go online and you search, it's identified as an NSA program. And you can go in there and you can flip one bit to shut the ME down. Intel confirmed it, they didn't deny it. The bit had been added at the request of the NSA. So the US government themselves considered the ME too dubious to run on their own systems. And so Intel built a private kill switch. We're going to zoom out now into a commercial context. Snowden's documents revealed that the NSA had been tapping the fiber links connecting Google's data centers around the world. They made a reasonable assumption. It's our machines, we own the buildings, and so we don't need to encrypt, we feel safe. But what they hadn't fully accounted for is you don't go from point to point when you go between countries. You go through a lot of different shared telecoms infrastructure, and that's when the NSA tapped them at those handoff points outside the US when they weren't subject to the same laws. And so because of this, it was near impossible to find these individual physical taps. So Google thankfully accelerated their plans to encrypt all their internal traffic. I'm not sure what the original timeline was, but I guess this was a good thing. Now, I want to apply this line of thinking to something many of this room are working on right now. Trusted execution environments. They are the mainstream answer to the question of how you run sensitive computation on hardware you don't control. So these words I think are familiar to most of you: Intel, SGX, TDX, AMD SEV, and the ARM Trust Zone. The premise is what happens inside the enclave stays inside the enclave. So the cloud provider running it can't see the data inside. But TEs have been broken consistently, and the pace is accelerating. So like from 2018 to 2026, we have a documented series of fails. The most recent one was TEE fail by a coworker of mine, Christina Garmin. And I saw this at a demo at RWC in Taiwan, where basically it's this big machine where you stick a lot of wires into the memory slot, and you're able to extract the attestation key. Some of these are extracting attestation keys, some are private keys, and some are basically screwing with the microcode so that you mess with randomness. And okay, so you think about this, but then remember we still have the management engine below Intel, SGX, TDX. And on Intel's own community forum, when somebody asked, can the management engine read enclave memory? The answer was, presumably, the security guarantees would be in effect. Why is this a growing problem? We're sticking everything we know, private and confidential, everything, like stuff that's important to us, stuff that's important to society, into AI models, whether they're hosted or local. The entire premise of private AI is that that will stay private. That assumes the TE boundary holds. But we've just seen evidence, 8 years worth, that it doesn't hold reliably. And actually, AI inference happens on GPUs, and we don't even have TE guarantees for that reliably across the board. So are we basically ushering ourselves into a totalitarian future by throwing everything into the ether? So I think that's why it's important to start caring about hardware now. The other thing is geopolitics. Like the supply chain for advanced semiconductor fabrication runs through basically a few countries. And you didn't choose these governments. You know, it's Taiwan, it's the US, and it's the Netherlands. They control the hardware, and you can't audit this. You can't audit any of these very close source proprietary firmware on top of it. This is the hardware gap. You can't close it with, working on better cryptography. You can't close it by working on more secure code. Which, about to close, brings me to Apple. It may sound like an ad for Apple, but it's validation for the importance of developing sovereign hardware. So over the last 15 years, Apple has systematically replaced different parts of their hardware, third-party silicon in their hardware with custom chips. Starting in 2010, I don't know if you guys can see this. 2010 is the A-series processor for your phones and your iPads. And then in 2013, they came out with their Secure Enclave. In 2017, they have the T2 for your Macs. And then finally, we're all familiar with the M-series in 2020, which replaced Intel entirely, thankfully. And finally, last year, they replaced the C1 modem, which is the radio layer. Remember the Mafia story? Their stated motivations were performance, cost, and supply chain control. But there is, thankfully, a very strong benefit of them now being able to market their increased privacy and security guarantees. The problem is, all of this is proprietary. Apple has built a phone where Apple is sovereign. I would love to have, one day for us, a phone where we are sovereign, where each component is open source and verifiable. The sanctuary phone. That's it. That's all I wanted to share. Thank you guys for showing up.
Any questions? I might have a quick question. What do you think, how secure is Venice versus other private AI service providers with their TE setups? It seems all still like kind of trust me, bro.
I think there are different ways to think about security. Like, did they think about whether they log any metadata, et cetera? Different companies have different quality of execution around that. And not all, so there is a GPU by NVIDIA that does extend the confidential confidential computing boundary from the CPU to the GPU. But I have a table which I didn't put there, like most of your big AI companies, they run on a diverse range of GPUs, and only some of them are on this confidential GPU. Yeah. Which it's scary for them too, because their model weights are not protected. Their model weight's worth almost $1 trillion per company.
Yeah, just go ahead, I'll repeat it.
So considering that Apple is like a blueprint of becoming sovereign, but has the closest you have like infinite resources, do you have a thought about how the ecosystem being able to access a reasonable amount of resources to achieve this?
Maybe you can try to repeat the question.
Yeah, he's saying, okay, Apple can do this, but the open ecosystem doesn't really have this. I think it'll be a very slow process. You do have, so one of the projects I work on, Project Sovereign, where we want to make an open, verifiable, secure chip. And we have found that in trying to raise funds a lot of philanthropic funds who are focused on future planning or like, avoiding the apocalypse, they are very interested in these problems. I'm not sure they're at the scale that we need them to be. They're definitely not on Apple, but there are interested and motivated people.
Maybe you want to use the microphone real quick. Sorry, I need to get the cable here.
Oh, thank you. Yeah, I had a similar question about Venice AI, because I was a big fan when they first started, and I started looking into it. And they were a little bit murky about where their GPU clusters sit and what types of GPUs they're using and how their whole privacy setup really works. So I was just wondering on your opinions about the current state of so-called private AIs, and how would you structure a private AI inference organization if you could wish it into existence?
I feel like this is a Colby question. How would you structure a private AI inference company system?
I mean, this is the classic like VPN provider problem. What's your jurisdiction? What are the lawful orders that can come from that jurisdiction to physically intercept the hardware? And how can you verify that the hardware really is what it says it is? And I think the quality of trusted execution environments isn't completely there. For example, I think part of the concept with Project Sovereign is that if the entity has physical access to the machine, then you can't trust the trusted execution environment. It's mostly just a facility design, so when you're in a multi-tenant workstation, you can pass some assurances on at a basic level. I don't know that it's something that you couldn't run an NSA Gov Cloud application on a mainstream consumer TE. I do think that what it does do in particular is it allows them to say they don't have the information. So if there's a lawful order to get the information, much like a VPN provider with no logs, they'll say they don't have it. But if entity was super motivated, they could probably set up an intercept on the local machine to get the information anyway, and just stick it right in front.
All right. Thank you, everyone. Yes, round of applause.